the printer, and if you can see that, the lid is sticking out at the tip there, and what happened was that the upper layers shifted out over this edge. I don't know if this little damn thing is just not good at focusing up close. Of course, the part's black, so what are you going to see, right? There you go. Now you can see it. See how it's shifted out? It should be a straight line, okay? So the whole upper layer shifted out, and it shifted out when this filament got trapped inside here and wouldn't unwind, and it just got so snug it held the print head and just held it back like a rein on a horse, and then finally it would snap loose, and then it took off again. But I didn't catch it. I wasn't here, and that's what happened. What I've been doing this morning is going through my alpha to beta, what happened, inspecting the print and looking at lessons learned. We found the stiffening support stuff was indeed not necessary. This new filament, when it seems to be working. The screw holes need to be sized properly. We're going to maintain the layers off with the tight filament. We're going to check that and make sure it's loose, and I'm going to try to stay here. And then we found that full fill, full density, and full quality really work. I mean, I don't know if you can see it, but the part just looks really nice from a side view. Even the bottom, the holes in had very little contamination. You could look in and see right through it. That's the inlet, and then back in the back is a little black hole. That's where the air is going to be sucked in, and this is where the air is going to be pushed out. And I've tested all of that, and it works really well. So that's some of the lessons learned. Some of the things we're going to do then is look at the differences between the data and the 3D and the design and the flyer version. Look at some material for structure and accommodate an assembly, making sure that it's easy to assemble, and make sure the filament's loose. And then I went ahead and looked at, okay, if I'm going to alpha to beta, what should I look at from an action plan point of view? And I'm looking at the differences, the depths, the widths, the things. The differences mainly on this one were the dang fan. The fan that I've been using is like this one, fairly good sized, robust looking fan. And I have to say, it puts out air. I mean, it really pushes air. The one that Lionel is using is this tiny little bugger. And what I'm wondering is, I'm going to go ahead and accommodate it. What I've done is I'm going to shorten the housing so it fits properly. And I'm going to test the flow and make sure. I know I'm getting lots of airflow. I might be able to get by with less airflow. Don't know. This one is 10 millimeters high. This one is 6. So it's about a 60% less airflow. I'm thinking I'll be able to get by with that as long as I can manage the heat on the coil. I also looked at the cavity to make sure I had enough room in there for the angel hair and all that, and I've compared it to everything we have, and it's larger or large as anything we have. So I'm looking at 6,000 cubic millimeters, and the Lionel is 6,000, and the old flyer was only 4. So I'm right up there with the Lionel, actually beating it a little bit as far as capacity, and so we're going to go with that. I'm going to look at some other parts. I don't know what I was looking at over there. So then we're going to look at action plan. We're going to make the lid, we're going to fix the plate, print the lid, do some testing, and then go from there. So I'm looking now at the beta. What do I need to change? I'm going to add the holes. I'm going to fix the lid and the plate, and I remembered now I got to make sure this plate fits. Is there anything I need to do? So that's what I was at. That's exactly where I was. I was fitting the plate as I designed it. I think I'm going to make it a little thicker. The new fan motor, I don't have one out, but the new fan motor has a much longer shaft, which is terrific. So I can use a different plate in between and have plenty of room for the fan to fit on it. So I'm fitting the holes, the screws, the countersinks, everything I need to fuss about this plate and making sure it fits. And the gap, I filled the gap. I don't know if you can see it or not, but right there I filled the gap with this glue. it has a pen, and you squeeze the glue out, and the glue stays soft until you shine a light on it. You shine this ultraviolet light on the glue, and then it becomes hard. Let me see if I can do a quick demo, because this has really been a lifesaver. So I'm going to put 2 dots down, one there and one there, okay? The first dot, I'm proving to you it's squishy. I moved it around. The second dot, I'm going to shine with this light, and now I'm going to try to push it around, and I can't. It's hard. It's cured. It's crazy, okay? So what you can actually do with this is like weld. You can sit here and just add structure, freeze it, add more structure, freeze it. You can actually build up a pile of this stuff, and it gets hard, and it's like epoxy almost. So what I've been doing is I'm using this as sort of an electronic welder. I'm just filling cracks. Oh, my tube is leaking. I think I'm running low on fluid. At any rate, that tool for the test and fab has been absolutely invaluable. Any rate, so I now have a good seal across the top where this was in error in the print because of the flaw. And now what I'm going to do is take the lid off, put the motor on, put the fan on, and build this up with the hair and fake a lid and just see how it works. That's the next thing. Later.